So hello everyone, this is lab number 4 from module number 7 in which we are going to learn creating a VPC. So the lab objective is traditionally networking is difficult. It involves equipment, cabling, complex configurations and specialist skills. Amazon Virtual Private Cloud, Amazon VPC hides the complexity and facilitate the deployment of secure private network. This lab shows how to build your own VPC and deploy resources. After completing this lab, we'll deploy a VPC, create a public subnet, a private subnet, an internet gateway, and attach it to a VPC. Create an application server to test the VPC. So task 1 is creating a VPC. So a VPC is a virtual network that is dedicated to your Amazon Web Services account. It is logically isolated from other virtual network in the AWS cloud. You can launch AWS resources such as Elastic Compute Cloud EC2 instance into the VPC. You can configure VPC by modifying its IP address range, create subnets. You can also configure route tables, network gateways, and security settings. Let's go to VPC. Select your VPC. A default VPC is provided so that you can launch resources. Yes. Let's create a VPC. Name is lab VPC. IPv4 CIDR is going to be this 10.0.0.0/16. Let's create VPC. Now choose tags. Tags are useful for identifying resources. For example, you can use a tag to identify cost centers or differentiate environments such as development, test, or production. Choose action and choose edit VPC settings. This option assign a friendly DNS name such as the following to EC2 instance in the VPC. For DNS settings, select Enable DNS host name. Choose Save. Any EC2 instance that are launched into VPC now automatically receives a DNS host name. You can also add a more meaningful DNS name such as app.example.com later by using Amazon Route 53. Next is task 2, creating subnet. A subnet is a subrange of IP addresses in the VPC. AWS resources can be launched into a specific subnet. Use a public subnet for resources that must be connected to the internet and use a private subnet for resources that must remain isolated from the internet. Task 2.1 is creating a public subnet. So let's go to subnet. Choose create subnet. VPC ID is going to be lab VPC. Subnet name, public subnet. Availability zone, shows the first availability zone in the list. IPv4 is going to be 10.0.0.0/24. Create subnet. Select public subnet, choose action, edit subnet settings. On the edit subnet setting for auto assign IP settings, enable auto assign public IPv4 addresses. Choose save. Next is creating a private subnet. Create subnet lab VPC. This is going to be private subnet. Again, availability zone can be anyone, and the IPv4 is going to 10.0.2.0/23. Let's create subnet. Now, as you can see, we have two subnet. One is private subnet and public subnet. Now, task 3 is creating an internet gateway. An internet gateway is a horizontal scaled, redundant, and highly available VPC component. It allows communication between instances in a VPC and the internet. It imposes no availability risks or bandwidth constraint on internet traffic. Internet gateway serves two purposes: to provide a target in a route table that connects to the internet, to perform network address translation for instances that were assigned public IPv4 addresses. In this task, you create an internet gateway so that internet traffic can access the public subnet. Let's choose internet gateway, create internet gateway, name tag is lab IGW, choose create internet gateway. In action, choose attach to VPC and select lab VPC attached to internet gateway. Now final task, task 4 is configuring route table. A route table contains a set of rules called routes that are used to determine where network traffic is directed. Each subnet in a VPC must be associated with the route table because the table controls the routing for the subnet. A subnet can be associated with only one route table at a time, but you can associate multiple subnets with the same route table. To use an internet gateway, a subnet route table must contain a route that directs internet-bound traffic to the internet gateway. If a subnet is associated with a route table that has a route to an internet gateway, it is known as public subnet. In this task, create a public route table for internet-bound traffic, add a route to the route table to direct internet-bound traffic to internet gateway, associate public subnet with the new route table. Let's select route table. Several route tables are displayed, but there is only one route table associated with lab VPC. This route table routes traffic locally, so it is called private route table. Expand the VPC column so that you can see which one is used by lab VPC. This one. In the name column, choose edit icon and name is going to be private route table. Save. Route. There is only one route. It shows that all traffic that is destined for this IP address will be routed locally. This route allows all the subnet in VPC to communicate with each other. You can create a new public route table to send public traffic to the internet gateway. Choose create a route table. Name is going to be public route table. VPC is lab VPC. Create route table. And let's edit route. Add route. Destination is going to be 0000. Target is going to be internet. Internet gateway. And IGW is going to be lab IGW. Now save changes. Choose the subnet association tab. Edit subnet association. Select the row with public subnet and choose save association. The public subnet is now public because it has a route table entry that sends traffic to the internet through the internet gateway. To summarize, you can create a public subnet by following steps: create an internet gateway, create a route table, add route to the route table that directs this traffic to internet gateway, associate the route table with subnet which becomes a public subnet. Now task 5 is creating a security group for the application server. A security group act as virtual firewall for instances to control inbound and outbound traffic. Security groups operate at level of elastic network interface for the instance. Security groups do not operate at the subnet level. Thus, each instance can have its own firewall that controls traffic. If you do not specify a particular security group at launch time, the instance is automatically assigned to the default security group for the VPC. In this task, you create a security group that gives user ability to access your application server through HTTP. So let's go to security group. Choose create a security group. Security group name is going to be app SG. Description is allow HTTP traffic. VPC is lab VPC. In the inbound rule section, add rule type is HTTP. Source anywhere IPv4. Description optional, so we are not going to give it. And let's create security group. Task 6 is launching an application server in public subnet. To test that your VPC is correctly configured, you now launch an EC2 instance into public subnet. You also confirm that you can access the EC2 instance from the internet. Let's go to EC2. Launch instance. Name is app server. Quick start. Amazon Linux. For Amazon machine AMI. Keep default instance type. Default key name and key pair is going to be vsc.key. Network setting, choose edit. VPC, choose lab VPC. Subnet, choose public subnet. For firewall security, choose select existing security group and then app SG. Configure storage, keep default, expand the advanced details. And for IAM instance profile, choose inventory app role. So this role was created when you provisioned the lab is required for the application to access database credentials securely stored in AWS Secret Manager. In the user data box, paste this value. In summary section, choose launch instance. Choose link to new instance. Check status, it's pending. This might take a few minutes. So after waiting for 2 to 3 minutes, now status checks is 2 by 2 check passed. Next is to connect to the instance. So I will select app server and open this address. It says if you configured the VPC correctly, the inventory application and this message should appear. Please configure setting to connect to database. Yes. Next is to submit the work. Application server is accessible, but it is not giving point for it. Again, uh, I got like 45 out of 50. So we have done all the steps correctly. Might be there is some misconfiguration, but although this lab is overall this lab is completed. Thank you.